It's exactly the same thing. So here we go. What do you remember about a tangent graph? It's been a few days since you guys did this. What do you remember?
Goes up and down.
Yeah, so the tangent is the one that has an asymptote and an asymptote and a dot at the origin, right?
That's keep fine.
So it's the squiggly line. And since that's a positive, it'll squiggle the way it normally squiggles, which is up. There it is. Now, with a tangent, are there any labels on the y-axis? No, because there's no top and bottom to this curve. It goes on forever and ever. So this 3 changes the curvature of the curve, but for us it's not going to have any impact. We're not going to worry about the 3 unless it happens to be negative, because that would turn the curve upside down, right? So I'm not going to worry about that 3, but I do have to worry about that 2. I know that normally these asymptotes would be where? What are the labels on the asymptotes normally? Negative 90 and 90. But because I put a 2 out there, I'm going to divide those by 2. Remember, this number divides my labels. So my asymptotes are actually at negative 45 and 45. Making my period what? What is my period? 90. Asymptote to asymptote, 90. And what is my amplitude for any tangent? None. None. There is no amplitude for a tangent. Remember, there's no ceiling and floor, so there's no height. Can't talk about amplitude for a tangent. All right, now this is a different shape. This is a sine.
Quick on the last one. So what is that? Like, if it's tangent, does that 3 do anything?
Changes the curvature, but that's all.
Okay.
And we don't have to reflect that because we're just doing a rough sketch.
All right. So we always just focus on whatever's in the parentheses, really.
If it's a tangent.
Yeah.
Yeah.
Okay.
Now, this is a sine curve. All right, so we got hash, hash, 1, 2, 3, 4, right? Sine curves start at the origin, original sin, sine at the origin. Now there's a negative out there, which means what? We're going to go down first. So your sine curve is going to have this shape. And we're trying to remember to put arrows on the end, but if we forget, that's okay. So there we go. That's our negative sine curve. Bo, you want to take your hat off, sweetie, in the building? Now, what about labels? What are my vertical labels going to be? 1/4 and negative 1/4. Making my amplitude 1/4. Now my horizontal labels are supposed to be what? What are they normally? 90, 180, 270, 360. That's exactly right. Those are the normal labels. But I stuck a 3 in here. So that's going to take all of those and divide them by 3. So my new labels will be 30, 60, 90, 120. Making my period 120 degrees. Okay? Now we got a cosine. sure what I hear dinging, but let me turn it off. So with cosine, we got hash, hash, 1, 2, 3, 4 again. Same setup as a sine. Now this is a cosine. So cosines, remember, are the weird shaped ones because of the period we graph from 0 to 360. So this is the shape of our cosine. We start at the top of the hill and end at the top of the hill. It's positive, so we started like that. What are my vertical labels then? 5 and negative 5? Meaning my amplitude will be 5. Now, what are my horizontal labels supposed to be? Normally, 90, 180, 270, 360. But we have a 1/2 out here, right? So we need to divide by a half. Meaning these labels, now you're dividing by a half. So you're multiplying by 2. So this would be 180, 360, 540, 720. So your period is 720 degrees. All this coming back. Now the last graph down there is going to be one of the regular curves. So it might just say graph y equals sine x, or y equals cosine x, or y equals tan x. So everybody's going to get one of those, just regular graph, no changes in anything. So that will be the last question. When I left blank, you're going to have one of those to graph, which should be easy if you can do these. Okay? All right, good deal. That's the quiz on tomorrow, or for some of you after school.